All right, homework day 7. We are simplifying complex fractions. A complex fraction just means you've got fractions within fractions. And this is really saying that you're taking 3/8 minus 1 divided by 7/4 plus 1. So if you wanted to check this problem with your calculator, we'll do that later. That's how you type it in. This top part divided by this bottom part, but on your calculator you'd have to use your parentheses. Without your calculator, the shortcut, and this is probably the alternate explanation, is to multiply each term by the common denominator. In this case, I have a denominator of this fraction of 8 and this one of 4, so my least common denominator would be 8. I'm going to multiply each of these terms times 8. With the fractions, I should be able to cancel the fractions out of there, right? So on the first one, the 8s are just going to cancel. 8 goes into 8 one time. 1 times 3, still 3 up there on top. Minus, here I'm just going to do 1 times 8 because I don't have a fraction, so I'm going to get 8. On the bottom, 4 goes into 8 2 times. 2 times 7 is 14. Plus 1 times 8 is 8. Now that looks a whole lot easier to do than the first thing, right? So on the top, 3 minus 8 would be negative 5, right? And 14 plus 8 would be 22. Now, of course, we know on Alex that on the answer, they'll put the negative out in front, but we get negative 5 over 22. So, I did it on my paper, going to check it with my calculator. I'm going to check it with my calculator. This is how I want to type it in. Start with the parentheses. 3 fraction eighths minus 1. Close the parentheses since I'm done with the top. Divided by parentheses 7 fraction fourths plus 1. Close my parentheses. Now, what shows up on your calculator?
Okay.
The right answer, right?
I was trying to do that last night, but it did.
So,
Must have been the parentheses.
the moral to the story is, because of the order of operations, we have to simplify this separately from this before we do our dividing, and to tell the calculator that, we put parentheses around it. So, if I move to number 2, it wants to go all the way down farther. First of all, if I do it without my calculator, my least common multiple here would be what am I going to multiply everything by?
2.
Nope.
Nope.
What are your denominators in your fractions? The 6 and the 7, right?
Oh.
So if I have a 6 and a 7, I have to use 42, which is 6 times 7, because they don't have anything in common. So although I'm going to use a big number, it's going to be okay. I'm going to take each term times 42. And I wrote 46 because I'm already thinking of the next part. Let's see if I can write a 42 there.
8, then you made me write it. 6.
So I'm then going to cancel. 6 goes into 42 7 times. So 7 times the 7 on top is 49. Okay, I'm done with that first one. The next one doesn't have a fraction. 2 times 42 is 84, right? On the bottom, 42 times 1 is 42, right? And then we have a fraction again. 7 goes into 42.
6.
6 times 10.
60.
So minus 60, right? So now on the top, we have to take 49 plus 84. $133. On the bottom, 42 minus 60.
18
Sign?
minus.
Minus 18. So we're going to get negative 133/18 because a positive divided by a negative makes that negative, right? Just for fun, let's check it with our calculator. Now the calculator probably will give you a mixed number first since we had an improper fraction and then we'll have to change it. But in parentheses, we're going to do 7/6 plus 2. Close my parenthesis, divided by, and then in parentheses, 1 minus 10 fraction sevenths. Close my parenthesis. When you hit equals, it says negative 7 and 7/18. To change it to the improper fraction, shift and the fraction button, negative 133/18. Okay? Try the next one on your paper. What's your least common multiple going to be? So I looked at that and said I have a denominator of 2 and a denominator of 4. I'm going to multiply everything by 4. If you used 8, 8 would work. Your numbers would just be bigger and you'd end up reducing at the end. Right? 2 times 4 is 8. I could use that if I wanted to. But I'm going to start out. 4 times 2 is just a plain 8 because I don't have a fraction to cancel with. Then I'm going to say, oh, 2 goes into 4 2 times. 2 times 7 is 14, so I'm going to have 8 minus 14 up on the top of my fraction. On the bottom, 4 goes into 4 one time. 1 times 7, just a 7 on the bottom of my fraction. So 8 minus 14 would be negative 6 over 7, which we know the negative would end up going in front. So negative 6/7 would be our answer. All right? The next ones. Again, trying to get across that complex fractions are really just division problems. This means that I'm going to take this top fraction divided by this bottom fraction. And when we divide fractions, what do we have to do? Flip it. I'm going to flip the bottom one. So I'm going to rewrite this. 15s to the 4th over 3t to the 5th u to the 3rd times the reciprocal of the bottom one. So 9t squared u over 5rs squared. Now it looks like those problems we were doing earlier, right? Just a little longer. I like to reduce my numbers, my coefficients first. 5 goes into 5 once and into 15 3 times. 3 goes into 3 once and into 9 3 times. I then like to multiply across the top and across the bottom just so I can combine stuff and rearrange stuff. I have a 3 times a 3, which is 9. And I have an s to the 4th, a t to the 2nd, and a u. On the bottom, 1 times 1, so I don't need that. If I put them in order, I have an r, an s to the 2nd, a t to the 5th, and a u to the 3rd. Again, you don't have to put them in order, but it looks nice when you try to rearrange them. Then I'm just going
why
to...
did you do that? Okay.
So everything lines up nice.
Oh, okay. I never thought of that one.
Because then I'm going to do some canceling, right? So I can take out 2 of my s's, which means I'm going to have an s to the 2nd on top. I can take out 2 of my t's, which leaves me a t to the 3rd on the bottom. And I can take out 1 of my u's, which leaves me a u to the 2nd on the bottom. So on the top, I have a 9s to the 2nd. On the bottom, I've got an r, a t to the 3rd, and a u to the 2nd. And that's going to be my answer then. Do I have to do this step? Probably not if I wanted to try to cancel in here, but it gets messy and people tend to leave things out, and that's why I like to rewrite it. I'm going to move the board so this is up a little higher for the next one. So number 5, we're going to rewrite this as a multiplication problem. So 7mn to the 2nd over 12x to the 3rd y times the reciprocal 3x to the 4th y to the 4th and 28n to the 4th. So we can do some reducing there, right? 7 goes into 7 once and into 28 4 times. 3 goes into 3 once and into 12 4 times. So on the top, I have an m, an n squared, an x to the 4, and a y to the 4. On the bottom, 4 times 4 is 16. And then I'm going to put the n to the 4th first, and then the x to the 3rd, and the y, just so they line up nice and neat. Then I'm going to do some canceling. I can cancel out 2 of my n's, which means I have an n to the 2nd down on the bottom. I can cancel out 3 of my x's, which means I just have a plain x up on top. And I can cancel out 1 of my y's, y to the 3rd. So on the top, I have an m, I have an x, I have a y to the 3rd. On the bottom, I have a 16 and an n to the 2nd power.
A 16.
Yep. 4 times 4, right?
Oh, you multiply them on the bottom? I was...
They're on the bottom, aren't they?
Okay, yeah.
Okay. It's on the tops, I just had 1s. On the bottoms, I had 4 times 4. So that's 16 down there on the bottom. All right, try number 6. All right, so I flip my second fraction around. I'm going to multiply. I'm going to say, okay, first of all, 3 goes into here once, into here 3 times. 5 goes into here once, and into 10 2 times. So when I multiplied, 3 times 2 is 6. I have an n to the 5th, a p squared, and a q. On the bottom, I have 1 times 1. I don't really need that. Putting them in order, I'm going to do the mn squared first, and then the p to the 4th q squared. Then doing my reducing. I can take out 2 of my n's, which means I have an n to the 3rd. I can take out 2 of my p's, which means I have a p to the 2nd down on the bottom. And I can only take out 1 of my q's, which leaves me a q down on the bottom. So on the top, I have the 6 n to the 3rd. On the bottom, the m, the p squared, and the q. There's my answer. Most common thing I see people do is forget this variable that's all by itself that they didn't have to do any canceling with, and they kind of forget it's even there. Number 7. Charlene likes factoring a lot, so we're going to do some more factoring. Trying to still get across that this just means this divided by this. So when we rewrite it, we're going to rewrite it as a multiplying. So I'm going to have the 4x squared over the 5x minus 35 times the reciprocal of the bottom. So the 3x minus 21 over 7x. Now on these first ones, we're just going to have greatest common factors that we can take out. Here, there's only one term. We're just leaving those ones all alone, and we're just going to factor these 2 things. So on the bottom of my first fraction, both of those are divisible by 5, right? So I'm going to make that 5 times x minus 35 divided by 5, 7. And then up here, both of these are divisible by 3, right? 3 goes into,
Yeah.
so 3 is going to be in front, and I'm going to have x minus 7 again, right? So I'm looking for my greatest, or my common factors that I can cancel out. Obviously the x minus 7, right? So the x minus 7, the x minus 7. I'm also going to look to see, is there anything else I can cancel? Well, I can't cancel the 4 with the 7 or the 3 with the 5, but I have an x squared and a plain x. I can reduce those down, right? I can take out one of my x's, which is just going to make that an x. So on top, 4 times 3 is 12, and I have that x. On the bottom, the only thing, all right, I have a 5 times a 7. I better do that. 5 times 7, 35. So number 8, I'm going to do that one. I'm going to leave the first fraction, 5x plus 25 over x. I got to multiply by the reciprocal of the bottom. So x to the 4th over 10x plus 20. So 5x plus 25 are both divisible by 5. So 5 goes out in front. And when I factor the 5 out, I get what in my parentheses? X plus 5, right? If I take a 5 out of here, I get just the x. 5 divided by 25, or 25 divided by 5 is 5, right? So that it should multiply back out. 5 times x is 5x, and 5 times 5, 25. The bottom one over here, both of those are divisible by
10.
10. So when I take the 10 out of there, what am I going to have left in my parentheses?
X. Oh, 10x.
Nope, you were right first time, just an x, because I took the 10 out.
Plus 2.
Plus 2, exactly. So now I'm looking for things I can cancel. This time I can't cancel the x plus 5 with x plus 2. They're not the same, right? But I've got a 5 and a 10 out in front. I can reduce those down. 1 and 2. And I have a plain x and an x to the 4th. If I take out one of my x's, that's now going to be x to the 3rd, right? So on top, just because it looks nice, I'm going to put the x to the 3rd in front and the x plus 5 behind it. If you write it in other order, it's okay. It just looks funny. On the bottom, I have a 2 and the x plus 2. And that's going to be my answer. So, go ahead and try the next one there. So there's really not a whole lot of factoring we can do on this one. The only place we can factor is down here in the bottom of the first fraction. My greatest common factor of 3 and 21 is 3, right? So that 3 is going to go out in front. 3x divided by 3 is just a plain x. 21 divided by 3 is my 7. Can't factor anything else. I'm just going to go to my canceling then. I can cancel out an x plus 7. And I look at my numbers. I got the 4 and the 28. I can reduce those down. 4 goes into there once, into 28, 7 times. I have an x to the third and an x to the fourth, which I can reduce down. I can take out the x to the third, which leaves me just a plain old x. So, what do I have left on the top? Don't say nothing. 1. There's a 1 up there, right?
Oh.
There's this 1. We got to keep that 1. Everything cancels out. There's always a 1 up there. On the bottom, we're going to take the 3 times the 7, so we're going to have 21x. And, oops, that's probably it, because everything else canceled out. I'll just fix that. 21x. So we ended up with just a 1 over a 21x. Crazy. Now, guess what? We're going to do the same thing, but now we're going to have those squared things thrown in there to factor. So, again, I have a fraction divided by another fraction. I'm going to invert and multiply. So the top's going to stay the same. 3x minus 6 over x squared minus 25. The bottom I'm going to flip. X minus 5 over 15. I'm then going to look to see where I can factor. On the top of that first fraction, again, that's one without the squared, so I look for my greatest common factor, which is 3. I can divide a 3 out of each of those. So 3x divided by 3 is just an x. 6 divided by 3 is 2, so I have 3 times my x minus 2. On the bottom of that first fraction, that has a squared term. I know I'm going to have 2 sets of parentheses. I hopefully recognize it as the difference of squares, but if not, I just factor it like I normally would. X and x. The end is negative, so we have 1 plus and 1 minus. Factors of 25. 5 and 5, right? And then here we can't factor, here we can't factor, so we're done with our factoring. We're going to go to our canceling. We can cancel out the x minus 5's, right? We can also reduce the 3 with the 15. 3 goes into here once and into 15 5 times. So on top, the only thing we're left with is the x minus 2, because we don't need to write 1 times x minus 2. On the bottom, we have the 5 and the x plus 5. So 5 times x plus 5. Number 11, same kind of thing. I'm dividing my fractions, so I'm going to leave the first one, 5x minus 15 over x squared minus 4. I'm going to multiply by the reciprocal. X plus 2 goes on top. X minus 3 goes on the bottom. So on the top of that first fraction, I can divide those both by... No, 5. You always want to get the answer first. The 5, and then I'm going to have x minus 3, right? The bottom has the squared. I know I'm going to have my 2 sets of parentheses. How's that one going to factor? x and x,
Oh, the
plus and a minus,
and a minus.
and then our 2 and our 2. We'll get to the 2's. Second fraction, there's nothing we can factor out. I don't have any squareds and I don't have any greatest common factors. So now I can just go to my canceling. I can cancel out the x minus 3's. I can cancel out the x plus 2's. That doesn't leave me a whole lot left. On the top I have a 5, and on the bottom an x minus 2. All right, go ahead and try the next one there. So the top of the first fraction, it's the difference of perfect squares. They just have the things switched around from how we're used to looking at them. But we don't want to switch the order. We just want to leave it alone, put our 2 sets of parentheses and factor it like we normally factor. So we're going to factor the 49 first. 49 would be 7 and 7, right? My signs, 1 plus and 1 minus, and then the x squared, x and x. Bottom we can't factor. It doesn't have a square, it doesn't have a common factor. The top only has one term. We're not going to do anything with that. But the bottom we can factor. Both of those are divisible by 3. So we're going to put the 3 in front and we're going to divide them each by 3. Again, we're not going to switch them around. 21 divided by 3 is 7. Negative 3x divided by 3 would be a minus x. Not a lot of canceling we can do there. The only thing I see that we can cancel is what?
The 7 minus.
The 7 minus x. There's nothing else there you can cancel. The 4 and the 3 don't reduce. I can't do a one-term thing with the two-term thing. And so my answer is that I have 4x to the 7th times 7 plus x up on the top. And on the bottom, I'm going to have a 3 and a 4 minus x. So as crazy as that looks, that's going to be my answer. All right, we're going to change our mind frame to radicals. These ones hopefully will be a lot quicker than those other ones were. First thing we're going to do, the square root of a perfect square. These are both perfect squares. 4 we know is a perfect square. When a variable has an exponent, if it's even, it is also a perfect square. When we do the square root of something with an even exponent, we take out half of that exponent because the index to the square root is really 2. They just don't write it there. We know the square root of 4 is 2. The square root of y to the 8th is going to be y to the 4th. If you took 2y to the 4th times 2y to the 4th, you get the 4y to the 8th. That's what a square root is. What times itself gives me this value underneath. So, if we are going to do the square root of 16x to the 12th, the square root of 16 is
8.
not 8?
4.
4. 4 times 4 is 16. The square,
Okay.
8 times 8 would be 64.
Oh yeah, you're right. Okay.
So the square root of 16 is 4. The square root of x to the 12th is x to the 6th. So if you took a 4x to the 6th times a second 4x to the 6th, you get 16x to the 12th. So what would be the square root of 36w squared?
No, wait, let me think.
What's the square root of 36?
What is the square root of 36?
Six, right? 6 times
Yeah.
6 is 36. You do have a square root button on your calculator. It's right over here, right? Right next to the fraction button. So square root of 36 is 6, because 6 times 6 is 36. What's the square root of w squared?
1.
W to the first, which is just w, right? So if you took a 6w times a second 6w, you get 36w squared. All right, the next one is writing either in exponential form or radical form. What they want to get across is that when you switch forms from a radical form to an exponential form, that the index to your radical is the denominator on your fraction. This is t to the 4th, and then I'm going to put the index on my radical underneath, so it's t to the 4/5 power. We'll get to numbers and do some numbers, so that's why they want us to know where everything's supposed to go. Number 17, they're just going to have you go the opposite way. So if I have y to the 3/2 power, the numerator stays with the y cubed. The bottom number is the index to your radical. Now we know, hopefully, that really we don't need the 2 in there. I just wrote it there for effect when I rearranged it. But when I do my final answer, I'm going to leave the 2 out of there, just like if it was y to the 1st, I leave the 1 out of there. But for square root, the 2 is understood to be there. We don't need to write the 2 in there. If I have the 6th root of b to the 5th power, how would I write that with an exponent instead of with the radical? B to what power?
Is it going to be 5, 6?
5, 6, exactly. That's what it's going to be. So that if I wanted to simplify something with a fractional exponent, what I'm going to do is rearrange it and write it as a radical expression. So, doing the same thing here, what we did up there, only now we have a number. 4 to the 5/2 would be 4 to the 5th, and I'm going to take the square root. Again, I don't really need that 2 there, I'm just going to write it for effect. Now when you simplify it, you could do the 4 to the 5th first, but then your number gets really big. So it's easier if you do the radical first. What is the square root of 4? The square root of 4 is
18. No.
square root of 4. 2, right? 2 times 2 is 4. Then I'm going to do the exponent that's next to that, right? So I did the square root of 4. Now I'm going to raise that answer to the 5th power. So 2 to the 5th. Two times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32.
Oh, I thought it was done. I was not paying attention to you. So
If
just
I-
go to-
If I'm going to do this on my calculator, the whole thing, I could do it in steps if I wanted to. This is how I have to type it in. 4 caret, and then in parentheses, you're going to do the fraction. 5 halves. Again, try to do it on your paper first and check it with your calculator, but go ahead, put in 4 to the 5 halves power on your calculator. We get 32, right? Okay. So, number 20, rewriting that as a radical expression. How would I rewrite it as a radical expression?
27. Power 3 or something?
Where's the 3 go?
Way over there.
It goes in the index, so I'm going to do...
What is it?
It's called the index. It's called the cubed root then. Cubed root of 27 to the second power, right? We're going to start and figure out what's the cubed root of 27. The cubed root of 27 would be saying what number times the same number times the same number 3 times would give you 27. 3, exactly. 3 times 3 times 3 is 27. So now I'm going to take the 3 and square it. 3 squared is?
27.
3 squared,
Oh.
right, to the second power. 3 times 3,
9.
9. Again, if you wanted to check it, you would do 27 to the 2/3 power. And you should come up with 9, right? So the last one, since we're running out of time, we are going to rewrite that first of all as a radical expression. So I'm going to have
Square root of 16.
not square root of
Okay, well.
16, but what number's down there?
Oh, 4.
Fourth. That's how you read that. 4th root of 16.
4th root, okay.
Raised to the 5th power. So we're going to start with the 4th root of 16. What number times itself 4 times would give me 16? Can't be a very big number, right?
4.
Now if you did 4 times 4 times 4
Oh,
times
okay.
4, it's going to be way bigger than 16.
Four. 2.
2, right? 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So the 4th root of 16 is 2, and then we're going to take 2 to the 5th power. We already did 2 to the 5th power earlier. 2 to the 5th power is 32. You might want to make yourself a chart that you keep somewhere in your notebook with your perfect squares and your perfect cubes and your perfect fourths. You probably don't have to do any farther than 2 to the 5th power, but you would want to do 2 to the 4th power, 3 to the 4th power, probably even 4 to the 4th power, and so forth. And your cubes obviously would be longer, and your squares probably even longer yet, because your numbers don't get as big
So
so
where do you
fast.
find that out?
Where do you find that? Well, you figure that out.
No.
2 to the 5th is 32. 2 to the 4th is 16. 3 to the 4th. You know how to do 3 to the 4th on your calculator?
Yeah, I
3
think.
caret 4?
Yep. 81.
81. What's 4 to the 4th power?
256.
See, I'm already getting a pretty big number, so I probably can quit with that list. Then I might do my cubes. If I need to add to it later, I can add it and make it longer. But that way I have it one place in my notebook, so when I'm trying to figure out, well, what's the fourth root of 16, I can say, okay, here's my fourth powers. 2 to the fourth is 16, so the fourth root of 2 is, or fourth root of 16 is 2.
I mean, you can't go to the internet and find this?
Maybe. I never looked. You could look on the internet, maybe it's there.
Gotta do something easy, you know.
All right. Our goal is to be about 23% done. I believe if you did everything up to where we're at, we really have 25% done. But next week, Tuesday, we're going to do 2 pages, but Thursday, we're only going to do 1 because we're at the end of the chapter. And so we'll have an easier day next Thursday. Thank goodness.
Oh my God, that's too much.